Okay, so that was syntax, and now comes semantics. This is lecture number 6, and semantics here is the big region in the middle that touches the local variables, all the equivalence table, and gets next token here and there from syntax routines. And then I divided part of it here into the part of TeX82 that's doing math. Well, this is all really semantics, and the math was just one big chunk of it. I'm not going to talk any more about math in this hour, except saying it's more of the same as what we're going to be doing. So the things that we're going to be talking about now is part of TeX semantics, and with math, it's just similar. And there you can find it in the code where there's special data structures for math. So in the dynamic memory, we not only have H-list node, V-list node, and so on, but we have different kinds of things called noads, N-O-A-D, that are used for the things that can occur there, like fractions and square roots, overline, binary relations, and so on. New data structures for math. And special part of the semantic routines that set up those data structures, print them out, and change them into the kind of data structures that the rest of TeX knows about. The big routine in math is called M-list to H-list. This converts an M-list, a math type list, into an H-list, a horizontal type list, and then the rest of TeX knows what to do with H-lists. So those are somehow sort of self-contained into a world in themselves, so I called it math on here, and it represents about 40% of the code for semantics in TeX. We'll talk about the other 60% in this hour, so that you get, and then those of you who want to look at the others should be able to follow that in the same way. To start out the semantics, I suppose we ought to talk about the big switch of TeX. This is the so-called chief executive, the program that takes over when TeX is running. Mentioned that TeX consists of lots of procedures, and then there's a little driver program at the end that starts the procedures going. Well, the thing that it starts going is called main control. And this is, where are we here? Chief Executive Section 906 on page 318. This is the hub of the web. This is where everything comes together. When I was writing main control, I had to get a new desk to work on. With the whole TeX program spread out all over the desk, because I had to be picking up, remembering what all the subroutines do, and all the naming conventions that I had used there, because I had my finger in several places always at once, because this is referring to the rest of the program and picks up the other things, starts them going at once. This part of the program also has been made a little bit more complicated to read, because it's inner loop stuff. When you're going through a paragraph and trying to set text, this is the high priority for the money of the thing. So the main control procedure consists of has been tuned in order to go fast on the text. So main control looks something like this. The big switch says get NC token, and then reswitch is another label where we could come back to in case we didn't like the token we got and we want to try again without getting another one, or we want to use it again in some other slight disguise. And here there's a bunch of little code for pause for interrupt. You can interrupt at this point, and you can also, tracing commands will print out the command that it got here. So when we were running yesterday and it said, here's where I got a blank space, here's where the letter B came through, that was at this point reswitch. But except for this diagnostic information, then it's a big case, and it's case abs of mode plus cur command of, and then we have a bunch of things that will be like vmode plus skip, and this would be for plus vskip, say, for a vskip that occurs in vertical mode, and hmode plus hskip might be another case. So here's another type where I split into many cases by adding together the current command to something. vmode has been set up, and hmode, they've been set up to be spaced apart so that these will all give us a unique division into cases. Okay. Now I suppose there's also an m mode plus hskip, because hskip is allowed in that mode. And then in most of these cases there will be there will just be a procedure call here, like I don't know what it'd be, but do glue or something. It won't be called that, but it will be a procedure call here, and it's called an action procedure. Then in your listing there will be another module, say there'll be called declare action procedures needed in main module, in main control, and another one of the action procedures will be procedure do glue, and then it'll actually do the thing that you want it to do for these three cases. The reason I separated this out is because a lot of people have to use Pascal compilers that put restrictions on how big a procedure can be. And so main control procedure, if I had all these semantics inside the main control procedure, it would way exceed this limit, especially on IBM machines which wants everything to fit into a small area that they can use only 2 base registers for. So main control consists mostly of this case statement and calls on procedures. The only exception is those cases that are really in the mainstream for the inner loop, something like, for example, hmode plus letter, hmode plus letter, hmode plus other char. This is what you find in the middle of text, and this is handled right in the main control procedure itself. And with the things that will look for ligatures and do those things. There are a few other things like spaces between words which were considered important enough to put most of their code, the common code for space between words, also in main control procedure. Now the cur command is one of these command codes. Section 201 lists all those command codes, Section 201 and the next ones, and we can take a look at those codes. We looked yesterday at page 201, we looked at the first 16 codes, but on page 202 it shows the next codes, and this extends way off. So we got code like charnum, that's for the \char, math charnum, mark, input, x-ray is the internal code name for show instructions, and make box, hmove, all of these are command codes for different things TeX has to do. All the way goes to the next page. Now on the next page, by the way, can we have the house lights on a little more so that people can read? Yeah, is that better? Okay, can you see it enough in the first row? Because you get some of the light from this guy. Okay. Thanks. Now the codes above max non-prefixed command, which changes from day to day as TeX gets larger or smaller, but it's now equal to 69. These codes up 70 and up to 91 here are all things that somebody might want to say is global. Or so on, maybe outer or def or something. But you have these commands that will take a prefix, and they're independent of the mode. If you really had to cut down main control further, and you had too many cases to handle, you could rewrite it so that reswitch would check if cur command is bigger than max non-prefixed command, then do a prefixed command. Else, do a case statement like this. Then you could cut down the definition of H mode. H mode is now, I think, 91. You could cut it down to 70, so that these branches, because all these codes 70 up to 91 are really done. You do the same thing for them, independent of the mode, and all of them really just call the one procedure called prefixed command. So I didn't do that now, because why should I add something to the inner loop some code to make an if test in the inner loop if it's not necessary? But you could cut down the size of main control by 3 times 20 cases in that case statement, since they all go to the same place and they're all consecutive, or 3 consecutive regions of the cases do that. Now the codes above max command are the ones that get NC token will wipe out. Undefined control sequence will not get through, nor will marks, top mark, bottom mark, call, long call, outer call, long outer call. These last won't even occur through the scanner. These appear in the EQ table, but they're only used to tell for purposes of when we are updating the data structure to tell whether we need to update reference counts or not. So these last things don't have to do with coming through get next at all, but these 6 here are taken care of by get NC token. So that's what the cur command will be, one of these codes. Now suppose you wanted to figure out how TeX does a certain thing. Like, let's try to figure out, suppose you didn't happen to know that X-ray was the internal code of show box, but you wanted to see, well, how the heck does TeX do a show box, okay? Well, the answer is, we look in the index under show box primitive. And for every primitive of TeX, there are 242 or 3 of these. They're listed in that same kind of a fashion, like show box primitive here is on page 430. And it's alphabetized under SH, not under backslash. There are 3 or 4 primitives that are only 1 character long, and those are indexed under single character primitives right here on that same page, fortunately, as showbox. There are 4 of them. And but otherwise the primitives are made out of letters, and so anyway, that'll refer you to where the primitive was actually loaded into the hash table. Every primitive is put into TeX hash table by the Initech program, and this particular one was done in module 1159. So if we turn to 1159, we will see, of course now we're paging around in this code without looking at the environment too much, but here we'll see a call on primitive procedure showbox. Now this procedure primitive is what's used to enter all the primitives, so I call it 242 times. And there's a module 218 says put each of TeX primitives into the hash table, and this is one of the things that belongs with that module because of the plus here. So all these that module 218 would refer you to all the calls on primitive if you really wanted a list of all the primitives. Now showbox then is put in with, and then here's the command and the chur, the modifier to the command. So the command code for showbox is X-ray, and the character or modifier is showbox code, so that if somebody writes showbox, what comes through TeX scanner is cur command will be X-ray, and cur will be showbox code, which we've defined here to be 1. Okay. Right after putting something in primitive, I also have a case of the print command and char procedure. There's a procedure that we have to use when we're tracing commands that's going to be used in reswitch here to print the thing out in symbolic form. It's not going to say you're doing command number 12, cur char is 1. It's going to want to say showbox. And so X-ray inside of that procedure is going to just is going to look at the chur code, and it's going to find showbox code there, so it'll print showbox with an escape character in front of it, and so then you'll see what came through. in this print command ensure procedure, it's supposed to be robust. It's supposed to be able to handle cases that can't ever really be there. There's no way for a TeX user to get command X-ray associated with any code other than these here. No, a TeX user can never enter something in the hash table whose command is X-ray. Only the primitive procedure is allowed to do this by any TeX, but you guys could do this by changing the web listing, doing something. You know, you can get anything into that EQTB, especially if you make a mistake. So this print command ensure procedure has to never give an error message specifically by calling error. It actually can be used inside of other routines, which we wouldn't want to lead to an error message, but it has to do something in all cases. Well, it's just going to say show in all those other cases. Sometimes if I think there's really a chance that somebody would want to know that it was a bad one, I would have rewritten this if I felt really it needed it, and I would have show code printing show, and the other cases would say unknown X-ray or something like that. But I want to make sure that the procedure does always have do something in every case that doesn't abort your job. So then show box comes through as X-ray. Well, what about now? How does that get acted on? Well, it's we could now find that by looking in the index under X-ray to see where X-ray is used, but that would refer us right back to the previous page. So to save time, we look here and we say cases of main control that don't depend on mode. One of them is going to be any mode X-ray, and it's going to call a procedure called show whatever. So show whatever is one of these action procedures I'm talking about, and most of the semantics are done by action procedures like that. And here it is in the next page there on module 1161. Declare action procedures for use by main control. One of the things is procedure show whatever, and this is it looks at the curvature, and if it's show box code, then it gets us to module 1164, show the current contents of a box. Okay, well, turn to page 1164. Show the current contents of a box. Scan an 8-bit integer. That's a special routine that calls scan integer, and if it's not between 0 and 255, it gives you an error message saying that it should have been between 0 and 255, and that it's changing it to 0 on you. Then we print a new line, and this greater than sign in box, and we print integer curval, scan 8-bit integer, puts its answer in curval. It's one of the reasons I wanted to use a global for this, because all the time I'm scanning something, and I don't want to have a new local every time for the dumb thing, and actually specifically assign it. But I got to be careful, of course, that it doesn't get wiped out by something else in the meantime. And that's the danger. The well-known dangers of global variables are that somebody else, if everybody uses curval, like if print new line would use curval, I'd certainly be in trouble. So you do this only when you know that your use of the thing is going to be near the time it was actually stored in a global variable. Otherwise, you're in trouble. And also, I couldn't do this. Well, if I made main control recursive, so that people would incorporate a whole TeX job inside of another one, then I would have to have curval be local to main control. All right, now print char equal sign. So box whatever is going to be equal to, and then we have two cases, but notice it refers to box of curval. This is a macro that refers to a position in EQTB, the current value of that box. And it's a pointer to the box. It's either an H list node or a V list node if the box is there. But if it's null, that means that there's no box there, and TeX calls that absent. Otherwise, we use the show box routine that displays all these boxes out in various lines using the show box depth and show box breadth parameters to cut off and explain how much is actually being shown. Then we give an error message, OK. That's not really an error, and the help message that goes with that was described on the previous page there. It says We saw it yesterday. This isn't an error message. I'm just showing something. But that's the whole thing. That's the semantics for showbox. And it's typical of a simple case of semantics. And there are 91 times 3 branches to this thing, so about 273 cases you switch into from this reswitch procedure. And one by one you check those off and make sure that TeX is doing the right thing on them. Okay. Now you want to add something to TeX. The extensions usually come through a single place. Let me see if I can find for extensions to TeX. We'll talk about that a second. Module 1209, right near the end, is where extensions are discussed. And it's worth reading that just to get a feeling for what you have to do. Suppose you add a new feature to TeX, how many different parts of TeX would actually be changed to accommodate that feature? Well, you've got to put a new primitive in the hash table. You've got to maybe put a new kind of what's it node type into your data structure. I see Lyle sitting here near the front row. He's put in the feature at Xerox that prints in color. So he knows what goes on in these things. But there's various places where you have to, where TeX would actually get extended, and I tried to make most of those all be possible to put them into this one place extensions and provide hooks into the main program that so that you don't have to affect the rest of it. I got a beep from something. Warning, 5 minutes to automatic log out. Let me see. Okay. Yeah. I don't know if I'll use the computer, but I wanted to be logged in just in case. Excuse me. So these hooks are shown in the sections there following 1209, and most of the case, though, we won't have to add a new command code if we're lucky. We won't have to add anything to main control because of because there's one of the command codes is called extension, and it just has a chur part that says what kind of extension you have. So if possible, when you make an extension to TeX, use extension as your command code and just give another chur field. And then the action procedure that you get is, let me see right there, 1216. Module 1216 is any mode extension, do extension, and calls the action procedure in 1217, do extension, which just is a case statement that implements the different extensions and gives confusion if it's an extension it doesn't know about. Confusion is an interesting error message. This is where TeX types out "this can't happen," but actually it doesn't type out "this can't happen" all the time. It's remembered whether there's been an error, at least one error before. If this is the first error that TeX has seen, then it says "this can't happen." But if the user has really screwed up before, it says something else. Let's take a look at confusion just to see so you get the idea what that is, because confusion is used for internal consistency checks in TeX. Confusion is defined in, you guys are fast, what, 90? Okay. Module number 90, page 32. Confusion, and so there's a global Boolean variable called spotless, and that is set ordinarily to true until you've got your first error. So if it's spotless, it says "this can't happen," then it gives the indication of what can't happen. It would say X1 in that case, and then it gives a help message there. Then that help message, by the way, will show up on your file. Let's see. Wait a minute. Because the succumb procedure, the succumb procedure is guaranteed to cause a fatal error. This is where it dies. But on the other case, it says "I can't go on meeting you like this," and then so you stop, but with a different help message. Okay. So that's what confusion prints on. Okay. Now back to extensions. I'm glad that some of you are chuckling. You know, I worked on this a little bit. Okay. Now, so the extensions occur in the hooks are indicated. Let's see, in like on module 1225, page 400. You'll see that I've made a what's it node have 4 subtypes for the 4 things that I'm treating as extensions in TeX. I'm considering open, send, close, and extend as if they were extensions to provide example paradigms of what you do for extensions. And so 1225 says in the case subtype it gives 4 cases. Otherwise, now this is for displaying a what's it node, so we don't want to give an error message. And so if we don't know what it is, we just print out what's it, and so don't say confusion in that case. But if we're copying a node, if we're copying a what's it node, that's one of the things we have to do. So module 1226 is something that belongs in section 200. And all of these hooks from the rest of the program have been filled in here in the extension section. And you certainly have to provide confusion message there if you're trying to copy a what's it node. You don't know how many words to copy, so you're in trouble. The what's it nodes are not of a given known size. Open node size is bigger than a send node size in this particular example, and the closed node size is 2 words, which turns out to be equal to the send node size, but it's a coincidence. There's a place where you have to return recycling nodes to the data structure. That's used in section 196. So 1227 is the code for wipe out a what's it node and go to done. And so you have to, if you extend TeX introducing a new kind of what's it, then you must also be able to create, print out, and free those nodes, and that's what these last 3 sections were about. Then there's a bunch of simple things that didn't affect TeX at all in the case of send, open, and close, but they might otherwise, so we still have the hooks. So 1228, 1229, 1230, 1231, all of these let's see, I think it would be good for the videotape people to show my finger pointing, even though the people in the audience can't see my finger too well. So in these cases, the modules are trivial. Like it says, incorporate a what's it node into an H box, and the code for that is do nothing. Do nothing that's a macro in web that expands into nothing. That's an empty statement. Let D be the width of the what's it node P. D is set to 0. So all of these are trivial things, but you have to, if you add a what's it where you want to do something, then you'd have to check on the what's it node's type and see that you were doing the right thing. Okay, so this gives an idea as to what parts of TeX would be affected if you add something new to the language. Whenever you add something new to TeX, you realize that you're making it impossible for your programs to run at somebody else's installation, and you have to. And I would strongly recommend that everybody keep a vanilla version of TeX around for those people who want to write programs for other users. That does not let it grow to the point where we can't share. Where we can't share anymore. A lot of effort has been put into this program to make it possible to be used in thousands of computer centers around the world, and we can do that if we keep our extensions in control, so that you'll also be able to have a change file that doesn't include all of your extensions. Somebody says, I want to write something that I know is going to work at somebody else's machine, then you should have one there. You should have a version of TeX that does that for them. Okay, now I'd like to follow one more thing through the semantics to finish so that we can get an idea of the rest of the semantics. And so let's try. Well, unless anybody has a better example, I thought I'd try following through an H box to something and then just make the list rather trivial. well, let's make a small H box and see what it does. So suppose I want to say H box to 100 points of the letter A. Okay, that shouldn't be a hard thing, but it'll actually take us through a little adventure through a lot of different parts of TeX. Okay, now first place we have to, well, let's think about what we imagine would be going on after you see H box. TeX has to look ahead and see if you specify something like to 100 point or expand by 100 points, or just if it's just H box with nothing after it. There are two cases of H box that you can see. One is where you give a particular size, and then the glue will have to be set so that you reach that size. Somehow we don't have any glue in here. It's too bad. Maybe I'll put a space after that, and well, if there was no glue, we might as well see what happens if there is no glue in the box. Okay. Anyway, one case is that we specify a final size, 100 points exactly. The other case is that we expand by a given amount, where this could be expand 100 points, and that would say take a natural size and make it 100 points or more. The special time when you write just H box and left brace, that's expand by 0 point. So we have these kinds of things that can occur. The specification of what kind of an H box we have. There's two cases: the expanding and the exact. And exactly. Then H box can be used in different contexts. It can be preceded by a lot of different things. For example, it could have been preceded by lower 2 points, and that means move it down 2 if it's in an H list. It could have been preceded by ship out, which says how it goes. It could have been preceded by leaders, which says this box is going to represent the replicating part in leaders, and that's going to be followed by glue. So there's various contexts by which this H box could have appeared, and we have to somehow remember then, as we're building up the H box, we're going to have to remember what we're going to do with it after we're finished with the box. So where does TeX remember that? Well, the answer is on the save stack. We also remember stuff like that. So yesterday I told you that the save stack was used for saving and restoring equivalence, and that it had this kind of we put fix-up instructions on the save stack. And then we had boundary words on the save stack too. Well, just after those boundary words or before the boundary words, whatever you want to call it, there's room for. It's a nice place to put stuff before you get to the fix-ups afterwards. Because if you're going to come back to this boundary word, it's going to be at a time when you know what kind of a boundary word it was. So the boundary word includes a code that tells you what kind of a group you're in. And in this case, we'll be in an H box group. When we finish an H box group, we'll be ready to read some stuff off of the top of the save stack that will tell us that this H box was being lowered perhaps by something, or maybe it was being put into leaders. Maybe there was a set box 100 equals this in front of it. All that information will be encoded on the save stack at the end. And so the save stack contains, below its boundary words, contains mysterious other information and then fix-ups occurring. Now there's a factoring problem involved here somehow. I mentioned there are different things that can come in front of it, like lower, leaders. I didn't mention set box, but that's another one. It's called save in the present TeX, but set box in TeX82. You might have said global set box, which is different from a local set box, and a few other things can precede can precede this. And then all of these operations can take any box. So these operations could apply to an H box, to a V box, to a V top, and a few other V split. There are a few other cases that make into a box. And so you have two things that multiply together: all the possibilities for how to use a box, and all the possibilities for how to make a box. And so TeX wants to represent all these combinations. First, these uses of a box put something on the save stack corresponding to the use of the box, and then all the different ways to make a box put something on the save stack saying what kind of box they're making, and everything is finally gloriously put together at the end. Now let's take a look at that's the general problem that had to be solved. When we look at the specific case, we want to keep a little aware of the environment of that case. Let's see if I can find out where HBox is done. Now let's see. Building boxes and lists is this part 46 that starts on page 326 in module 932. But it starts getting into boxes. Let's see. On like module 939 tells how it's going to represent the context of the box. And the context of the box, in the simple case that we just have an H box in the middle of some other list with nothing else in front of it, the context is going to be like lower by 0, because it's going to be treated as a special case of lowering or raising or moving left to right, where the amount of shifting is 0. So the context code for that is going to turn out to be 0, but there will be a context code placed on the save stack. So when we scan HBox, it's going to come through. The command code for that is make box, and all of these different contexts are going to insist that make box command is the next one. Otherwise, there will be an error message saying I expected a box specification here or something like that. And the any mode make box comes through on module 951, and so module 951, the last two lines of that any mode make box saved 0 is set to 0 begin box. Now saved 0 is an abbreviation for save stack of save pointer plus 0, and saved 1, the same thing for sticking in a 1 here. So this means it goes at the top of the save stack. Save pointer minus 1 is where the information that's really at the top of the stack goes, and 0, this is the first place that's available on that stack. If any of you looked at the code for save stack, it's made sure that there's always 5 or 6 places available before it checks again to see whether it's run out of save stack space. The test, we don't have to test here whether or not there's room on the save stack. That test has already been made that there's always room for 5 or 6 things. Because whenever it does test, it's at a point that it's guaranteed never to put 5 or 6 things on before the next test. So we don't want to be testing all over the place. Okay, so now saved 0, in other words, this position on save stack is set to 0, indicating equivalent to a shift amount by 0. Because if I had, okay, so some of the other possibilities for getting the context code are described in other models. I don't want to go into that. So we got 0 in that position. Then we call begin box, the begin box subroutine. And unfortunately, I was not able to write the begin box subroutine next because it calls end box, so, box end subroutine. And I had to declare box ends first. The reason is that when I begin a box, I don't know. All I've seen so far is a make box. I don't know that I'm making an H box. This might be some simple thing like instead of H box, I might have just said box 20, in which case I would be able to finish the box right away. something like HBox, I'm going to have to wait and scan this whole thing, which might be arbitrarily long before I finish the box. But I might finish it very simply. So I call begin box now. Begin box is module 958. And that's what then is going to look at and see what kind of make box we're supposed to make. And in this case, we have other cases. Initiate the construction of an HBox or VBox. Because let me see, where's my call on primitive for HBox? It must be around here somewhere. The HBox primitive is, bottom of page 330. HBox primitive for HBox is right here, and it's the command code is matebox. Its char code is vtop code plus hmode. So that's where we are here. HBox gets a vtop code plus hmode, and so the hmode is going to tell us what mode to go in when we reach this point. VBox would look very similar, but it would have vmode in there instead. So as far as TeX knows, it's got the command code of makebox, and then its char code is going to be vtop code plus either vmode or hmode or 0. And these are the three cases that we're coming into in module, now this is 962. So module 962, here is where module 962, here's where we make enter restricted horizontal mode or internal vertical mode in order to make a box. And so the first thing is we stuff away kerchar minus vtop code into a local variable k. The value of k will be 0 for vtop, otherwise it'll be vmode for vbox or hmode for hbox. We increase the save pointer. That means then that we have now officially put this guy on the save stack. It's in order to make room for the next thing, and we call scan spec subroutine. The scan spec subroutine is what scans this part of the input. Expand or 2 followed by 100 points. And it puts two things on the save stack. One of them is either 0 or 1, telling whether it's 2 or expand. And the other one is the dimension, 100 point. I guess there's no point in going to look at the scan spec subroutine, but it just calls scan keyword, and then it puts those two things on the stack. I believe it also increases the save pointer by 2, so that we now have put 3 things onto the stack, telling us the context of this box as well as the final dimensions of the box. Now we still have k, which tells us what was going on, although kerchar has changed many times because the scan spec procedure is called getNext, of course. K equals hmode, then we call new save level hbox group. So the save pointer, the save stack is now going to get a boundary word for an hbox group. Then we're ready to know when the right brace comes along that we're in an hbox group, and so the thing to do is to package up our hbox. We'll see that in a minute. But we put on the save stack then a boundary word that refers us to an hbox group, and our current group, the current type of thing we're in, is going to be hbox. Otherwise, for vbox and vtop is similar. Things go. Then we say push nest, and here's something we want to know about. In TeX, it has a stack for all the semantic activities for various kinds of lists, and this has state information analogous to the input state. Remember when we were talking about syntax last hour? The syntax would have a state and loc and limit, and there were a few other things we didn't get into, but like the name of the file you're reading is part of your state. The semantics also have a stack of these things, and one of the things is the mode that you're in. That's a current part of your semantic state, and then you have the head and tail of the list that you're building. So if you're in horizontal mode, for example, you're building a horizontal list. Head points to the beginning of that horizontal list. Tail points to the end of that horizontal list. the space factor is another part of the of your mode of your state as far as semantics is concerned for building horizontal lists. So we would so when we say push nest, this says all the state variables that go into semantics, save them away in your nest stack for semantics, and so that they'll pop up again later when we're done with this. But they all get saved. And so we're pushing some things on the save stack and some things in the nest stack. Well, it turned out to be convenient to do that. And then we set mode to -k. Now k is either H mode or V mode. So it's the mode, the value of your current mode is 6 possibilities. There's vertical mode and the V mode and -V mode. -V mode is internal vertical mode, and plus V mode is what you have when, on the outermost level of TeX building pages. Then there's H mode and -H mode. -H mode is restricted horizontal mode. That's what you have in the middle of an H box. Plus H mode is the ordinary horizontal mode, which you have for building a paragraph. Then there's M mode and -M mode. Plus M mode is in a displayed math formula. -M mode is in a text math formula. So those are the 6 modes, and that's part of your. And so when you say push nest, it saves away your mode and your head and tail of your current list, your space factor or pre-depth or whatever was a part of the mode there, and also presents you with a fresh new mode, a brand new mode. You now got an empty list that you're building. So your head is now pointing to a special location in memory that's just going to be the head of this list. It's not really an element of a list, but it's a base of the thing, and the tail is pointing to the same place, so that is representing an empty list. The mode, when I say push nest, I stay in the same mode I was in. But now I change it to -k, which is -H mode or -V mode, so now I'm going to make either a V box or an H box. And I have to initialize the space factor in the case of horizontal mode, so I set space factor to 1,000. 1,000 is the normal space factor, meaning don't make any correction to spacing. If space factor was 2,000, it would say double your stretchability in the spacing, and half your shrinkability. And then return, which means go to exit, get out of the procedure for begin a box. So now this is a simple case of post-hypnotic suggestion. Here's where we now return to main control, and we go back into TeX, and we have our fingers crossed that someday, somewhere, a right brace is going to come along, and we're going to be able to finish this H box. But we fearlessly let TeX run with its head, do whatever it wants to now to this H box, and all kinds of things can happen before we ever get back control again. Those things will presumably be our state will presumably be pushed down on either the save stack or the nesting stack or both. Whenever something even more complicated comes along. But someday we're going to get back, and a right brace is going to come along and take us out. Well, what does come along? In this case, wait a minute, where did I say scan left brace? Oh, the scan spec subroutine actually scanned away the left brace too. Why not? Because one of the things it could have been was H box left brace, and why should we have to back up? So it takes away the left brace too. Scan spec subroutine is only used in 2 places, here and after H align. V center, I guess, another case. Okay, now, so we've pushed our previous mode into the nest, and we're in a fresh mode with an empty list. Next thing comes through the scanner is H mode plus a letter A. Okay, do we have time? I guess we have time to do a little bit of this. Well, I won't go through all the details. We certainly will have to check now for the character following A to see if it's part of a ligature, and whether kerning is needed and things like that. Well, I'm not going to go through all that code. But H mode plus letter is the case recognized in module 907, and it tells us to go to main loop. And main loop is in where? Main loop is in that same module 907, and it says append. Okay, here we go. Main loop is append character curvature and the following characters, if any, to the current H list in the current font. Go to reswitch when a non-character has been fetched. 910. So 910 is all that action, and this is inner loop, so we're trying to be fast here. F is set to cur font. This is the internal code of the current font. If it's undefined font, then we're not inner loop anymore, and we call a procedure for missing font and go back to big switch, do nothing. But let's suppose F is not an undefined font. Then we set C to the current character, which is the internal code for lowercase a, 97. And we got main loop 1, which is a label that's been explained on the previous page. It said main loop 1 is like main loop, but F and C are the current font and character. So that's, I guess, a correct description of what main loop 1 is. Now here we have to check to see whether this is a valid character in the font or not. So he says, is it less than font beginning character or greater than the font ending character? Because this font might be valid, okay, but it might not have this character in it. And if so, then we have a char warning procedure which gets called, and we again ignore the character. TeX will never put in its data structure a character that doesn't exist in the font. The output routine never has to check whether a character is there or not. That's already been done before we ever put it in the data structure. So we get through this test, and main loop 2, I bet you if I turned back the page and gave the camera operator more fits, it would just say that it was like main loop 1, except that the character also is in the right range for the font. So then we set a couple other variables that are going to help us on our ligature, space loop, and but the gist of it all is that we're going to finally get to main loop 3, which is going to finally put a character into the current list in font F. What that means is the following. I've got now, when I said push nest a minute ago, that meant that I had a pointer variable called head, which gets pushed down at each level, pointing to some new word of memory, which is null. It has a null pointer in it and nothing there. This represents an empty list. And tail is also pointing to this same place in memory to represent the empty list. Now when I get a new character A, what I'm going to do is make up a char node, which is one of these nodes that goes in the one-word memory, and tail is going to point to it. So I'll say get avail, and in fact I'll use a special case of get avail that doesn't call a subroutine unless it's unless it's one of the hard cases, because I'm in the inner loop. Anyway, I get an available one-word node, and I'll have a null pointer in here, but I'll make this one point to this one, and tail will point to this one, and it'll say F here and C here. The font and the character will be stored in that node. F is already known to be in the correct range for a quarter word, but this 97 code for ASCII, I'm going to have to add min quarter word to it in order to get it in there. Anyway, I'm going to have a font and a character and then a null pointer at the end of that. If this list got any longer, let's suppose I had a space there. I won't go through the code, but I'll tell you what happened. If I put a space here, what would happen? We'd look at the current font F and say, what's the glue for that current font? And in most cases, there will be a pointer to a glue specification for that font. If not, we'll make up such a pointer so that later on we can do it in one step. There will be a pointer to a glue specification, so then this will point to tail. We move to a new word, which is glue, and this would be glue, which refers to the glue for the current font. There's a little packet that says how much to stretch, how much to shrink, how much to space for spaces in each font, and even the undefined font has one of these, which are all 0. But this glue will point to this word of glue specification, and there's a reference count in this word saying how many people are pointing to it, so that this will disappear when there's no more uses of it. But this glue is a very compact thing. This one has to specify 3 32-bit numbers. So we don't want to waste that much space in TeX. We get by with that with just pointing to it, and have a reference count in here so that this will go away when we don't need it. So this is a 1-word node for the character, a 2-word node for the glue, and we've built an H list that contained 2 items in it. When we made this space, we checked the space factor, that the space factor was 1,000. Therefore, we could use the standard glue for the font. Otherwise, we would have diddled with it a little bit. Okay, that's what we did. Then A in a space. Then a right brace comes through, and here's where this is another big thing. When TeX sees a right brace, almost anything can happen depending on what that right brace means. And let's see, where does a right brace come through? I think it's oh goodness, I need some help on this right brace. Anyway, there's if I went in handle right brace is the procedure. So when a right brace comes through, then we call handle right brace, and 964 is the module number. No, 964 is the one that's used in 947. Yeah. Okay. 947 is the procedure handle right brace. Here we are. And it has to deal with all the things that can occur when a right brace occurs. Now, there's a lot of error situations that we want to detect here. Like suppose somebody said $, and then he had a right brace before he finished his formula. Well, $, is also considered to go on the save stack with a boundary word, and so to the left and right. And there's also now something called group begin, which will give you local variables just like left braces do. So there are things so the right brace might match something that isn't a left brace. We have to check for that, decide what to do. We have to decide, for example, in this case, whether or not the guy forgot a $, or whether he put in a right brace that he didn't want to. So those cases have to be handled. But in this case, we're lucky. So we got a right brace, and what happens? It calls case Kerr group of. Kerr group for us is an H-box group, so it must be in cases of handle right brace where a right brace triggers a delayed action, 964, and then it's going to finally take us to module 979. No. Let's see, 964. If I looked in the index under H-box group, I would find it. Yeah, well, here it is, 964. Okay. So H-box group says call package of 0. And V-box group says end a paragraph in package of 0. So package of 0 must be the thing that is going to wrap this thing up into a neat little package, and that's on the next page, 965. And package of the parameter is going to tell whether it's a V-top or not. Is the only other case. Unsave. This is what goes through all the fix-ups on the save stack. So it goes back to the previous boundary word. Anything that's been declared in here, if I had any defs in here, font changes in here, they all get undone by the unsave procedure. Well, then I've got back to the point where there's 3 words on the save stack that are telling me what kind of box I was supposed to make and what the use of that box was going to be. So I decreased save pointer by 3 more, and now those 3 things are saved 0, saved 1, and saved 2. Here I check to see what kind of mode I'm in. If negative H mode means I just finished a restricted, an H box, a restricted horizontal mode. So that's what applies. So I set curve box to HPAC of link of head, save 2, save 1. Okay, now HPAC is my packaging subroutine. Talk about that in a sec. Link of head, well, here's head, the top of the list. Link of head is the beginning of the list. So when I call HPAC, I want to know where the list starts. And I also have these 2 things on the save stack that said it was 200. That says it was 200 points. So I want to make it 800 points exactly. And HPAC is the subroutine that's called the packager, and it's the main way to take a list and make it into a box. It's sort of the way. HPAC and VPAC are the 2 things in there. The packaging subroutines which come right here, packaging, page 196, 554 packaging, and that section is devoted to creating to the HPAC subroutine. HPAC subroutine essentially runs through this list, figures out how big it is, so it'll finds character, font F, character C, and from that it looks up in the font information and sees how wide the character is, how high it is, how deep it is, so we can compute the depth of this H box. It looks at the next thing, it's glue, and it records how much stretchability there is, whether or not it's infinite and whatever. And gets to the end of the list, says, see, I'm supposed to make it up to 100 points, makes up a new box node that says the glue is stretching by a certain factor. This is the height of the box, this is the depth of the box. HPAC does all those nice things. And returns a pointer to the box it made, the box node it made, and as we saw, that pointer gets stuffed into cur box. Okay, that's what we're in handle right brace somewhere. Well, I got lost and we're getting short of time. But that's the one. So the right brace has taken us through that much. And if I could find my code back again here on boxes, building boxes, I bet you what would happen next is that I would pop the nest and go back to my environment. But wherever that is. Page 335. Okay, here we go. Yeah. So curve box was set to HPAC, and then we pop the nest, which means that we get, by this time we've got another pointer to this list already. This list is now pointed to by some box node or other, and head is still pointing to it. But I wipe this node out, I recycle it, put it back into free memory, and then I call the box end procedure. The box end procedure is going to take cur box and add it to the current list in the outer mode, and it'll either lower it or raise it or put it in liters or whatever the context on save 0 tells it to do. So there we are. We finished an H box. Now that's taken us through a lot of the ideas of TeX, and I think by that example you'll get a feeling for what other things are going to happen. Anything could have happened inside this H box. Of course, it could have called a V box. That could have had a displayed formula inside of the V box and all that other stuff going on. But it's all done with the same basic ideas. We save some things on the nesting stack, some things on a save stack, and we have a few vital procedures like the HPAC procedure that make transformations on the data structure. Finally, everything gets into the data structure, and we're ready to do things like break it into lines for paragraphs. And that's that's the subject of the lecture at 2 o'clock, breaking paragraphs into lines. The most interesting one that I want to especially recommend is the one at 3:30 on hyphenation. We should have some fun with that if the computer is still up, because the brand new hyphenation algorithm in TeX, and I want to show you how it works and do some experiments with it. So this afternoon, well, both of them are pretty good, but the hyphenation one will be the most fun for me.